Yeah, so for example, the idea of elimination is like if you have multiple equations, then you want to do stuff to the equations so that if you were to like add or subtract the equations in some way, then like the variables will go away. So like I think again, it'll make more sense if we were to have an example. So let's say we had the equations 4x minus y is equal to 9 and 3x plus 2y is equal to 4. Let's say we want to solve like these equations, I guess. Um, of course, we can use substitution on this question. Like it's definitely possible by, for example, taking the first equation, and we can add y to both sides and subtract 9. We would get y is 4x minus 9. And then again, we can use the same strategy by replacing this y with like this y with this y, so that you have a one variable equation only in terms of x. And you can do it that way, just like we did in the previous question. But right now I want to like demonstrate the other technique, which is elimination, which might be like they essentially do the same thing except like they look different. So the technique is called elimination. So in elimination, you want to basically choose any of the variables. Like you can choose x, you can choose y. It doesn't matter what variable you choose, and your goal is gonna to be like to try to eliminate it in some way, right? So like if you look at the first equation, 4x minus y equals 9, like we might, one thing like we might want to do is we can try multiplying the first equation by 2. It's like that might seem kind of weird, but like we'll just see like why we should do that. So if you multiply this entire equation by 2, right? You multiply by 2 on the left side and you multiply by 2 on the right side, you get 8x minus 2y equals 9 times 2, which is 18. And it turns out with equations, you can just like kind of add them together. Like you just add these two expressions together, like these two equations together. And basically you add the stuff on the left side together and the stuff on the right side together. So you would take 3x plus 2y, and you would add that to like 8x minus 2y. And on the right side, you get 4 plus 18, and you have 22. And that's why we kind of multiply by 2, because now we have a plus 2y and we have a minus 2y. So these kind of cancel out. And that's like why we initially multiply by 2 in the first equation, because normally we had a minus y in the first equation and a plus 2y in the second equation. So if we wanted to directly add the equations there, the y's wouldn't cancel. But if we were to multiply the first equation by 2, which is what we did here, and then add them, then the y's would go away. And the reason you want a variable to go away is because now you have like 3x plus 8x is 11x. And on the right side, you have 22. You have like essentially, again, a one variable, one equation system. So if you were to divide by 11 on both sides in this equation, you get x is equal to 2. And again, now that you have x equals 2, you can plug 2 into any of these equations. Like maybe we can plug it into this equation over here. And we can solve for y. So we would do 3 times 2. Like remember, x is 2, so we replace x with 2, plus 2y, and this has to equal 4. So 6 plus 2y has to equal 4. So you subtract 6 on both sides, 2y is negative 2. And you divide by 2 on both sides, so you get y is equal to negative 1. And yeah, so this would be your answer. X is 2, y is negative 1. And again, if you're like not confident that you did something right, like you think you might have made a mistake or something like that, you can always like, it's always a good strategy to like take x equals 2, y equals negative 1, and plug it back into like the system of equations, like in the very beginning, and see if like the equations are all true. And if they are, then you did it right. And if they're not, you might have done like something wrong. So yeah, that was the idea with elimination. Like it's pretty similar to substitution, except like it's kind of done in a different way, sort of.